Hello EngiMates, my name is Harshil Shah. Welcome to our EngiMate channel. You will find everything regarding engineering in a simple and understandable way. Major disciplines like medicine, aviation, transportation, supply chain, manufacturing, engineering are going through massive transformation from using drones for site service and deliveries to using AI for diagnosing diseases and treating patients. Technology plays a huge role behind this transformation. Major industries like construction, mechanical, electrical are using BIM and digital twinning to create advanced 3D models and interpret data. For the sake of today's video, let's understand digital twinning at a much greater depth. So what actually is digital twinning? Digital twinning is the process of creating virtual representation of the physical object, processes or systems. It uses simulation and real-time data to create the physical counterpart of the object, monitor the performance and predict outcomes. Digital twin models are not only restricted to buildings and cities. Digital twinning can be done for anything and everything. For example, if I want to understand the consequences of exceeding the design air crushing speed of an airplane, I can create the digital twin model of the jet engine and run the engine at let's say 1000 kilometers per hour, and I'll be able to know the consequences of exceeding the design crushing speed. Let's say my car manufacturing assembly line is facing delays, but I am afraid of trying out new results because it might lead to cost overrun or it might make the situation worse. I can create the digital twin model of the entire assembly line and can try out new alternatives on the digital model before executing it physically. This saves time, energy as well as cost. Now let's understand the basic background of digital twinning. Digital twinning is not relatively a new term. It has been used by NASA since 1960s when they wanted to create and simulate conditions for the Apollo 13. Dr. Michael Greaves in 2002 used it for product lifecycle management and termed it as an underlying model for product lifecycle management. Things changed and years passed on. Finally, in 2010, John Vickers of NASA finally coined the word digital twinning in his roadmap report. Let's understand the basic difference between a digital twin model, beam model, a 3D model, and simulation. A 3D model is just a static representation of an object. Think of a toy car. Simulation is a dynamic representation of the object. It contains movements, behaviors, and reactions. Think of a toy car with a moving engine. Now, a beam model. To understand beam model, we'll take the example of a residential house. So, a beam model will contain all the 3D model data. Along with it, it will contain material and specifications and dimensions like wall profiles, roofing and flooring details, and the dimensions as mentioned. Now, a digital twin model will contain all the data in the beam model along with the live sensory data such as temperature, energy use, occupancy details. These data can be used to predict outcomes and monitor performance. The basic difference between a digital twin model and a beam model is that data in digital twin model is collected automatically through sensors while the data is to be entered manually in the beam model. Now let's understand how digital models are created. We'll use the example of residential construction for simplification. To create a digital twin model of a residential project, we'll follow these four steps. The first one being collection of data. We will use technologies like drones and other devices to collect as much data of the existing house as possible. Apart from that, we'll also refer to construction drawings as well as other specifications to get an idea about the different structural elements, materials used, as well as dimensions of the house. Once this is done, the second step is to create a 3D model using applications like Revit and SketchUp. The third step is to install sensors in the house to collect data about the temperature, energy use, occupancy, details, and much more. We'll also link this data to our 3D model. The last step is to interpret the data according to our means. There are basically four types of digital twin models. The first one is the component twin. Component twin. In this twin model, individual components are digitalized. For example, in a digital twin, creating a digital twin model of a beam or a column or a wall. The second one is the asset twin model. In this type of model, multiple components are combined together, just like a residential house. The third one is the system twin model. In this type of twin model, multiple assets are combined together. For example, entire residential scheme or entire subdivision scheme. The last one being the process twin model. In this type of models, entire process is digitalized and a digital twin model of the entire process is created. Now let's understand the pros and cons of digital twin modeling. The first advantage is it offers real-time monitoring. Because sensors are attached to the object, we can get a real-time status of the object. The second advantage is the innovation. We can try out various different alternatives which can help us save time, energy, cost, and which can be environmental friendly as well without actually executing them on the real object. The third advantage is the enhanced decision making. Using advanced insight, we'll be able to decide, we'll be able to take a better decision. Now let's talk about disadvantages. The first disadvantage is the high initial cost. Because of we need more technological support at the initial stage of this of using digital twin, the initial cost would be higher. The second disadvantage is the data management and data security. Because this data is very sensitive, and if this is accessed by an unauthorized person or entity, it might lead to data mismanagement. The third disadvantage is that these digital twin models depend a lot on modeling as well as accurate data interpretation. If this goes wrong, the entire purpose of doing the digital twin model will eventually fail. And the last but not least is the complex model management. Digital twin models can get up to very large sizes, and these models, for example, of cities, are very complicated to be managed once they reach this much size. Now let's talk about application of digital twinning across various industries. Starting with number one, production. As discussed before, entire production or manufacturing line can be digitalized. Various solutions can be tried out which can save time, money, cost, and which can offer environmental friendly solutions. Siemens Electronics factory in Germany created digital models of control panels and power electronics. These saved time as well as cost and offered environmental friendly solutions. These increase their production by 50% and reduce their carbon footprint. The second sector to benefit is the healthcare. Patients' behavior can be simulated for advanced treatment and diagnosis. Apart from improving the existing infrastructure facilities, Siemens radiology department in Ireland faced the challenges of efficient patient handling. They turned to digital twinning for solution. They retested the building layout and tried out various operational phases. These increased the handling process, increased the efficiency of patient handling, and reduced the staffing cost. The third sector is the aviation. NASA pioneered the use of digital twinning in this sector. The main use of digital twinning is to check the performance and reliability of the vehicle by assessing the damage caused, by inspecting the vehicle thoroughly for safety features, and by providing real-time update. The fourth sector is the construction. In any construction phase, digital twinning is very useful. For example, from creating 3D exceptional models to executing, to predicting the maintenance requirement and executing a demolition in an environmental friendly manner, the digital twinning is very useful. The fifth sector is the manufacturing. Just as in construction, in the entire manufacturing process, the digital twinning is very handy. During the design phase, it can help select the optimum design. During the manufacturing phase, it can automate order execution, and in the operational phase, it can gather data and analyze it for the user purpose. The sixth and the last segment is the automobile. Digital twinning can be used to create digital twin models of engine, suspension, transmission, and various vehicle factors like fuel economy. Having understood the application, now let's turn our focus to understanding when to use digital twinning, what are the reasons of failure of digital twin models, and what are the future aspects of digital twinning. Digital twinning should be used whenever the problem it is trying to solve is complicated, it's recurring, and it's substantial. Digital twinning will offer a solution that is cheaper, efficient, as well as environmentally sustainable. Second thing to keep in mind is that enough quality as well as quantity data should be available. Having said that, let's focus on the what are the reasons of failure of digital twin models. The first one is the lack of need. Whenever there is no need, especially of digital twin models, it simply won't work out. The another reason is the high initial wrong setup might lead to wrong interpretation and then the subsequent failure. Initial setup and modeling is very important for digital twin models to work out accurately. Last but not least is the lack of quality as well as quantity data. The future of digital twinning is very promising. AI as well as advanced other technologies will be more integrated. Digital twinning will focus more on sustainable solutions, and it will be used across various diverse industries. That's it, guys. We had a complete overview of the entire digital twinning technology. We understood that digital twinning is the virtual representation of the physical object used to monitor performance and predict outcomes. Then we discussed how digital twin models differ from a BIM model. Model collects data through sensors and updates it automatically, while in a BIM model, it has to be entered manually. Then we had a look at how digital twin models are created and what are the pros and cons of digital twinning. Lastly, we touched upon the various applications of digital twinning across diverse industries and what are the future possibilities, what are the reasons of failure, and when to use digital twinning. If you found any value in the video, please like, subscribe, and share. I'll see you in the next video. Then keep engineering.